there's always that one individual so selfless and caring. The world still has caring people.
Welcome to the 2018 edition of the National Science and Math Quiz. This is the 25th 1A stage contest, and it features St. Hubert Minor Seminary and Senior High School, AWUDOME Senior High School, and ACCRA Academy. Let's meet the contestants. ACCRA Academy. ACCRA Academy is represented by
Nicholas, final year.
Final year.
You're welcome, gentlemen.
Thank you, madam.
How are you doing?
We're fine, madam.
Hey, you seem so busy already. Well, you need to chat with me for a little bit. I need to find out a bit about you.
Yes, well.
All right. But you are coming from the prelims.
Yes.
What happened there?
Well, at the prelims, we met Anglon, Afiedinigba, and St. Mary's Boys SHS. And by God's grace, we're victorious. So now we are here.
All right. That's good. And I've been trying to find out about our contestants. What do you do when you are not doing science and math?
Well, I read interesting stuff, like how things came about in the history of stuff. Yes.
In the history of stuff.
Yes, yes.
I see.
Yes.
So what is the most interesting historical stuff you've come across?
Well, nuclear reactors.
Oh, all right. That's still science and math, though. What about you, Jerry?
Madam, please. I like playing football. And also, I like reading storybooks during my leisure time.
I see. The football. Playing or watching?
Both.
Both?
Yes,
okay,
please.
so World Cup so far, what do you think?
So far, I'm busy with science and math, so I'm not.
Oh, you haven't focused. You're too busy. Oh, okay, that's good.
Thank you.
All right, so let's come back to the science and math. What should we expect from you today?
Madam, please, with God on our side, victory will be ours.
All right, best wishes to you then.
Thank you, madam.
AWUDOME Senior High School. AWUDOME Senior High School is represented by
Cheka Bernard, final year.
Avenue Deborah, final year.
You are welcome, lady and gentlemen. How are you doing?
We are fine, very well.
AWUDOME Senior High School. You are coming from the prelims. Yes. What happened there?
At the prelims, we met KSTS, Koforidua Sectec, and they gave us a hard time, but we managed to qualify for this round.
All right. Well, there's no KSTS here this time.
Yeah.
All right. Let me find out a bit about you. What do you do outside of science and math?
I play table tennis.
Table tennis. Yeah. Okay.
I sing a little bit.
Sing. Aye, Madam Deborah. Can you sing a few bars for us?
Maybe after the contest.
After the contest. I keep getting promises. Will you deliver on your promise? Okay. All right. Now, this contest, what should we expect?
The best.
The best. Yeah. Best wishes to you. St. Hubert Minor Seminary and Senior High School. St. Hubert Minor Seminary and Senior High School is represented by
Sammy Emmanuel, final year.
Dear Frank, final year.
You are welcome, gentlemen.
Thank you.
Please, will you take a moment to chat with me? All right, you are seated school. What did the seniors tell you? Isaac Newton and Co., right?
No.
That was before. All right. Philemon, okay. What did they say?
We're here to complete what they started. We are here to complete what they started. That's what they told us.
All right. Okay. And when you are not doing science and math, what do you do?
Watching football.
Watching football.
Yes.
Watching movies and playing games.
Watching movies and playing games. You gentlemen are too busy. See, I even feel guilty wasting your time like this. As I'm talking to you, you are focusing on your things. All right, I'm going to leave you. But what should we expect from this contest?
Okay. We are here to honor the Lord. So, as we have this opportunity, let His perfect will be restored.
All right, best wishes to you. Viewers, we've met the contestants. Some of them are so busy that they can't even chat. But that's all right. I won't get upset. I will just finish my thing, sit down so that we can quickly go through the contest. All right. Before I sit down, though, I would like to acknowledge that the National Science and Math Quiz is sponsored by the Ghana Education Service through the Conference of Heads of Assisted Secondary Schools. We also have support from GCB Bank, ACCRA College of Medicine, Medifem Multi-Specialist Hospital and Fertility Center, Lancaster University, Ghana, Academic City College, West African Center for Cell Biology of Infectious Pathogens, WACBIB, Awake Purified Drinking Water, GTP, MFA Jewelry, and Hottie Makeup. The mentorship sessions are sponsored by Bond Savings and Loans and RMG Ghana, and SciTech Fair 2018 was sponsored by GOIL, Prudential Life Insurance Ghana, and Talo Ghana Limited. Our media sponsors are City FM and Joy News. This is a prime time production. My name is Elsie Fakofman, and I'm your quiz mistress. Contestants, the contest, as always, comes to you in 5 rounds. The first round is a round for fundamental concepts. The questions are simple and direct. I'm expecting simple and direct answers from you. If you answer your major question correctly, 3 points. If the question is incorrectly answered, it becomes available to the 2 other schools. A school may ring and attempt an answer. If the answer is right, a bonus point. If the answer is incorrect, it fetches a penalty, 1 point. For questions that require calculations, you have a maximum of 30 seconds to present your answer. If there are no calculations involved, you have 10 seconds to do so. All questions, all of them, are to be attempted once only. Best wishes to all 3 schools. I'm going to start with you, St. Hubert. And this first set of questions will require 10 seconds of your time. In which direction do electrons flow in the external circuit when a voltaic cell is used as source of power? How different is it from an electrolytic cell? Yes, dear.
Okay, in the voltaic cell, electrons flow from the positive to the negative. And in the electrolytic cell, electrons flow from the anode to the cathode, and the anode is the negative, and the cathode is the positive. So
That's incorrect for bonus. All right, so in the voltaic cell, it's from the anode to the cathode in the external circuit, and there's no difference for the electrolytic cell. Same. All right, so AWUDOME, define an electrode potential of a half cell. Okay. Yes, Deborah.
The electrode potential of a half cell is the EMF read when the half cell is connected to a standard hydrogen electrode.
I'm not going to accept it. For bonus. All right, so is the potential measured as voltage for an oxidation form or oxidized form of a substance to be reduced? Now, ACCRA Academy. How can the electrode potential of a hypothetical half cell M+/M be obtained? Yes, Ajari.
Madam, please, it can be measured by coupling it with a standard hydrogen electrode at standard conditions of 298 Kelvin and a standard pressure of 100 kilopascal.
One. Yes, so yes, you do have to set up a voltaic cell with the hydrogen electrode, the H+, H2/PT, that would be the anode, right? Then the electrode potential of the hydrogen electrode is arbitrarily set as 0. So the potential is equal to the experimentally determined EMF. Next set, 10 seconds each, and I have a preamble to all schools. When I get to your school, I will mention a structure in an organism, okay? So state the function of the structure indicated in the organism. Did you get the preamble? All right, St. Hubert. Gill rakers of bony fishes. Yes, Emmanuel?
The gill rakers are used for further feeding in the fish.
Yes, feeding. AWUDOME, with the same preamble, radula of land snail. Yes, Deborah?
The radula is used for feeding.
Yes. ACCRA Academy, with the same preamble, uropod of crayfish. Yes, Ajari?
Madam, for feeding.
That's incorrect for bonus. The right answer is locomotion. Locomotion. 30 seconds. In an isobaric expansion of a fixed quantity of an ideal gas, the volume of the gas changes from 20.0 meter cubed to 50.0 meter cubed. Find the initial temperature of the gas if its final temperature is 127 degrees Celsius. Yes, Emmanuel.
160.0 Kelvin.
All right, I'll give it to you, but note significant figures. How many was I looking for? Are you sure?
One.
Where's?
Okay.
I'll come back to you in a bit. All right. AWUDOME. The temperature of a fixed quantity of an ideal gas changes from negative 23 degrees Celsius to 127 degrees Celsius in an isobaric process in which the initial volume of the gas is 5.0 meter cubed. Find the final gas volume. Which of you? Bernard?
Yeah, that's 80 meter cube.
That's incorrect for bonus. Yes, Raphael?
6.0 meter cube.
That's incorrect. The right answer is 8.0 meter cubed. Your major question, ACCRA Academy. Find the final temperature of 4.0 meter cubed of ideal gas, which undergoes an isobaric process in which its initial temperature is negative 73 degrees Celsius, and its final volume is 9.0 meter cubed. Yes, Raphael?
177.0 Kelvin.
That's incorrect. Yes, which of you, please? Deborah?
450.0 Kelvin.
Again, significant figures. I'm going to give it to you, but now, this significant figure issue, I think physics consultant, you need to do some tutorials. I understand even the physics teachers are complaining that they don't know what we are looking for. This is unbelievable. All right? Okay, so for you, St. Hubert, your values, I gave you the values for volume to 3 significant figures. I took the time to add 0.0 just to make it 3 significant figures. And then the values for the value for temperature, I gave that to you, nearest whole number or 3 significant figures. So the answer should also be comparable, shouldn't it? So what should the answer have been? You told me 160.0. What should it have been?
160 Kelvin.
Yes, 160 Kelvin. ACCRA Academy, you too. Or no, it was AWUDOME that got the bonus. I took time. Volumes were to 2 significant figures, 4.0 meter cubed, 9.0 meter cubed, then the temperature, nearest whole number. So what should your answer have been?
450.
450 Kelvin. You did study these things in first year, didn't you? So why? What is creating all this confusion? All right. I took time to explain for a reason. From quarterfinals, no forgiveness. Next set, 30 seconds. The preamble is simplify. Simplify. All right, so now, St. Hubert, n factorial over n minus 3 factorial, the expression n minus 3 factorial. Yes, dear.
Okay, we have n squared minus n1 bracket, multiply another bracket, n minus 2.
I'm not going to accept that. Yes, which of you? Bernard.
N squared minus 3n plus 2.
No, that's incorrect. The right answer, and I wasn't even expecting you to expand, but the right answer is n multiplied by n minus 1 multiplied by n minus 2. All right, if you wanted to expand, actually, you would come up with n cubed minus 3n squared plus 2n. All right. So AWUDOME, with the same preamble, the expression n plus 2 factorial over the expression n minus 1 factorial. Yes, Deborah.
N plus 2, that's an expression. Multiplying another expression, n plus 1, multiplying n.
Yes. ACCRA Academy. The expression n plus 1 factorial over the expression n plus 3 factorial. Yes, Raphael.
We have 1 all over the expression n plus 3 multiplying the expression n plus 2.
Yes. "30 seconds. Preamble to all schools. Preamble. Fe2 plus ions can be oxidized by a solution of Cr2O7 2 minus in acidic medium, and the equation for the expected reaction is as follows. Cr2O7 2 minus plus 6 Fe2 plus 14H plus going to 2 Cr3 plus 6 Fe3 plus 7 H2O. That's the preamble. Please, did you get your preamble? Great. All right, so St. Hubert, calculate the volume of 0.0120 mole per meter cube solution of K2Cr2O7 that will react completely with 24.0 centimeter cubed of acidified 0.0800 mole per decimeter cube solution of Fe2 plus. Please give your answer to 1 place of decimal. Yes, Gia.
Okay, madam, we have 2.7 times 10 to the power 2 centimeters cube.
That's incorrect. Raise your hand. Yes, Raphael?
Now we have 26.7 cm cube.
Yes. AWUDOME. In a determination using 20.0 centimeter cubed of 0.0120 mole per decimeter cubed of K2Cr2O7 solution, what volume of 0.100 mole per decimeter cubed H2O will be needed? Please give your answer to 1 place of decimal. Bernard.
Yep. 0.0400 mole per DMQ.
That's incorrect. Which of you, please? Raphael.
16.8 CMQ.
That's right. Your major question with the same preamble. Calculate the concentration of acidified Fe2 plus solution if 25.0 centimeter cubed of it required 20.0 centimeter cubed of 0.0150 mole per decimeter cubed of K2Cr2O7 solution for complete reaction. Please give your answer at least 3 significant figures. Raphael.
0.072 mole per DMQ.
2 out of 3. You know why? Significant figures. 0.0720 mole per decimeter cubed. Ten seconds. And I have a preamble to all schools. In biodiversity and conservation, to what do the following descriptions refer? So I'll give you a description. I'm expecting you to give me a biological term that refers to the description. Got it? Wonderful. All right, so St. Hubert. Species with limited distribution in a particular geographical area. Yes, Emmanuel.
Endangered species. Endangered species.
That's incorrect for a bonus. It's an endemic species. AWUDOME, with the same preamble. Species that strongly influence structure and function of an ecological community. Deborah.
Endangered species.
No, for a bonus. Keystone species. ACCRA Academy with the same preamble. The most important cause for the loss of biodiversity. Yes, Ejare.
Variation.
That's incorrect for bonus. The right answer is habitat loss. Next set, 30 seconds. St. Hubert. Find the impedance at an angular frequency of 100 radians per second of a circuit made up of a 4-ohm resistor in series with a 2 millifarad capacitor. Yes, dear.
Up 2 root 5 ohms.
That's incorrect. Please raise your hand. Yes, Raphael.
Root 41 ohms.
Yes. AWUDOME. Find the angular frequency at which the impedance of a series RC circuit with R equals 40 ohms and C equals 2 millifarad equals 5 root 65 ohms. Did they make it on time? Okay, go ahead, Bernard.
Yeah. 20 rad per second.
That's incorrect. Yes, the two of you from Accra Academy. Which of you? Raphael.
25 rad per second.
No. The right answer is 100 radians per second. Your major question. Find the capacitance of a series RC circuit with R equals 20 ohms, for which the impedance of the circuit equals 20 root 5 ohms at an angular frequency of 50 radians per second. Yes, Raphael.
5 millifarad.
Pardon?
5 millifarad.
That's incorrect for bonus. The right answer is 0.5 millifarad, or 5 times 10 to the power negative 4 farad. Last set of questions, 30 seconds, with a preamble to all schools. Preamble. Find two positive integers such that, that's a preamble. St. Hubert, their mean is 38 and their difference is 12. With the same preamble, their mean is 33 and twice the smaller number less the larger number is 9. Yes, Deborah.
25 and 41.
You're right. Their mean is 22, and one number decreased by twice the other number is 5. Raphael.
One is 13 and the other is 31.
Yes, that's right. And that's the end of the first round. At the end of the first round, St. Hubert Minor Seminary and Senior High School has 9 points. AWUDOME Senior High School has 9 points. ACCRA Academy has 10 points. Ladies and gentlemen, you can do better. Revive yourselves and let's move into round 2. Round 2 is also known as a speed race. The questions in the round are directed to all 3 schools at the same time. For an opportunity to answer a question, you must ring for it. May I hear your bell? Accra Academy. Thank you. AWUDOME. Thank you. St. Hubert. Thank you. If you ring and answer correctly on the first attempt, 3 points. On the second attempt, 2 points. On the third attempt, 1 point. Be careful though, because if you attempt to answer a question and you are unsuccessful, you lose a precious point. For questions that require calculations, you have a maximum of 30 seconds to present an answer. If there are no calculations, you have a maximum of 10 seconds. Best wishes to all 3 schools. Let's make this a proper speed race. Okay. First set of questions, 30 seconds each. First one. Determine the surface gravity on a celestial body of radius 400 kilometers and escape velocity 200 meters per second. Raphael.
50 meters per second squared.
That's incorrect. The right answer is 0.05 meters per second squared. You misplaced your decimal point.
Per second squared.
By the way, if you don't raise your hand, I am at liberty to call either one. And I'm going to start doing that.
Okay. 50 meters per second squared.
Carry on. All right. Next one. A curve in a racetrack banked at 45 degrees to the horizontal has a radius of 40 meters. What is the largest speed at which a car can... Yes, Duya?
20 meters per second.
You're right. And the rest of the question was, at which the car can negotiate the curve without skidding if no friction exists between the road and the tires of the car. All right, next one. The current gain of a bipolar junction transistor in the common base configuration is 0.8. Find the current gain of the transistor in the common emitter configuration. The right answer is 4. Next set, 10 seconds each. No, not each. First in the set, 10 seconds. State exactly where one can find 4 radial vascular bundles in plants. dicot roots. Next one, 30 seconds. How many mitotic divisions are needed for a single cell to make 256 cells? Raphael.
8 mitotic divisions.
Yes. Ten seconds. The tunica corpus theory is connected with which part of a plant? The shoot apex. 30 seconds. Hematite is a well-known ore of iron comprising an oxide of iron Fe2O3. Calculate the percentage loss in mass when a mole of Fe2O3 is reduced to metallic iron. Atomic mass for iron is 56.0, that for oxygen is 16.0. Dia.
35%.
That's incorrect. The right answer is 30%. 30%. Next one, and the second one is 30 seconds, and following from the previous question, the question we just finished. FeO can also be reduced to metallic ion. In which reduction is the percentage loss greater, and by how much? Atomic mass for iron is still 56.0, and that for oxygen is still 16.0. Yes, Raphael. Go.
Madam, the percentage loss in the Fe2O3 is greater. This is because the percentage loss is 30%, but for the FeO, it is 25%, so it is greater than the FeO by 5%.
That's incorrect. Who rang next? AWUDOME. Yes, Bernard.
The percentage loss in Fe2O3 is higher, and the difference is 7.97%.
That's incorrect. Yes, the loss is greater in Fe2O3, but the difference is 7.8%, not 7.9. 7.8%. For the speed race, everything has to be correct. All right, last in this set, 10 seconds. An ore of iron consists of FeS2. What is the name of this ore? Yes, Raphael.
Iron pyrite. Iron pyrite.
Okay, I'll accept it. But the proper pronunciation is pyritis. Iron pyritis. "30 seconds for the set. Last set, 30 seconds. Find the measures of two angles which are supplementary and their difference is 48 degrees. Which of you? Deborah.
That is 114 degrees and 66 degrees.
Yes. Solve for x from the equation a multiplied by the expression 2x minus 3b is equal to c multiplied by the expression dx minus 3. Yes, Emmanuel.
And then we have S equal to 3b minus b all on 2a minus cd.
I'm not accepting that. Who rang next? Yes, Bernard.
We have x equals 3ba minus 3a all over 2a minus
I'm
cd.
not accepting that. They didn't ring. Okay. Bernard, give me your answer again.
3ba minus 3a all over 2a minus cd.
Okay. The right answer is 3 multiplied by the expression ab minus c all over the expression 2a minus cd. Last question. 30 seconds. Evaluate. Limit as x approaches 1 of x squared minus 1 all over the expression x squared minus 3x plus 2. Raphael.
Negative 2 over negative 2.
Okay. That's the end of the second round. Thank you. Don't turn over until I ask you to, and don't begin until I ask you to. At the end of the second round, St. Hubert Minor Seminary and Senior High School has 10 points. AWUDOME Senior High School has 10 points. ACCRA Academy has 17 points. Round 3. This round has the problem of the day. The problem of the day is a single question to all 3 schools. From the time I ask you to begin, you have 3 minutes in which to compose an answer to the problem of the day. The problem of the day is worth 10 points. Please put down your pens, and let's turn over our sheets and read the problem of the day together. Problem of the day. A. Distinguish between Bremsstrahlung and characteristic X-rays with respect to the nature of their spectra and the mechanisms of their generation. B. An electron is accelerated through a potential difference of 5.0 kilovolts in an X-ray tube with a copper anode. The copper K-edge or K-shell ionization energy is 8.98 kilo electron volts. And a copper K alpha photon has energy 8.04 kilo electron volts. 1. Determine the wavelength of the most energetic Bremsstrahlung radiation emitted by the tube. 2. Determine the magnitude of the linear momentum in Newton second of the most energetic Bremsstrahlung radiation emitted by the tube. 3. Explain why no copper K radiation is observed in the radiation emitted from the tube. And 4. Determine the linear momentum in Newton second of a copper K alpha photon. Contestants, this is your problem of the day. You may now begin. Please stop writing and present your answers. Is your school name on there? Is your school name there? Thank you. Thank you. ACCRA Academy. Which of you wrote this? Is you. You write it exactly like this on the board for me. I can't read it. I'm having serious difficulty. For example, what is this? You write it like that. We'll all judge to see if you can read or not. Contestants, please pick up your notepads and present your answers on the boards as you have them here, exactly. Hey, Jerry, I'm serious. Write it as you have there. Hey, you can honestly tell me that this is fine. Camera, what does this look like? And there's more. Let's look. You've captured it. We shall talk about it. The contestants have presented their answers. Before I award the points, let's look at the suggested solution from the consultants. This is a problem in physics about Bremsstrahlung and characteristic X-rays. Very interesting. So the first part of this was for the contestants to distinguish between Bremsstrahlung and characteristic X-rays with respect to the nature of their spectra and the mechanisms of their generation. So Bremsstrahlung is characterized by a continuous spectrum. That's a proper language, continuous spectrum, whereas characteristic radiation is characterized by a line spectrum. The Bremsstrahlung is emitted when a charged particle is decelerated, whereas characteristic radiation is emitted when an inner shell vacancy in an atom is filled by an atomic electron. Okay, 1 point for each of these, making 2 points. All right, then the B. We are told that an electron is accelerated through a potential difference of 5.0 kilovolt in an X-ray tube. So we have an electron accelerated. And this tube has a copper anode. The copper K edge, or K shell ionization energy, is given as 8.98 kilo electron volts, and the copper K alpha photon is given to have an energy of 8.04 kilo electron volts. Contestants were to answer 4 different questions. The first one, they were to determine the wavelength of the most energetic Bremsstrahlung radiation emitted by the tube. Okay, so this is how to go about that. If you want to know the wavelength is given by Planck's constant multiplied by speed of light divided by the energy. The energy is given, but not directly. So we know that we have an electron that is accelerated through a potential difference of 5 kilovolts. So we need to get the energy from this value. Okay, and we get it by multiplying that energy, that value, 5.0 kilovolts, by 1.6 times 10 to the power negative 19 coulomb. That will convert that to energy. We need to work in SI units so that we can have nice values also in SI units. Okay, so now we have the energy. We can now complete our calculation. So Planck's constant, 6.6 times 10 to the power negative 34 joules second, multiplied by speed of light, 3.0 times 10 to the power 8 meters per second, all over this energy I have just told you about, 5.0 times 10 to the power 3 volts, multiplied by 1.6 times 10 to the power negative 19 coulomb. If you do the calculation, you should arrive at 2.475 times 10 to the power negative 10 meters. Now we need to do some round off because this value has way too many significant figures. So we round off to 2.5 times 10 to the power negative 10 meters. 1 point for process, 1 point for final answer. Okay, so next, we are to determine the magnitude of the linear momentum in Newton second of the most energetic Bremsstrahlung radiation emitted by the tube. So we are going to continue from where we left off. We got the energy from before. Now we need to calculate the linear momentum in Newton second. Okay, there's a relationship. The linear momentum is given by the energy over speed of light, and this is equal to Planck's constant over the wavelength. We've already calculated the wavelength in the first part, so we're going to use that value to get the linear momentum. So we take Planck's constant, 6.6 times 10 to the power negative 34 joule per second, divided by what we calculated as wavelength previously. So divided by 2.475 times 10 to the power negative 10 meters. And if you do the calculation, you should arrive at 2.7 times 10 to the power negative 24 Newton seconds. 1 point for process, 1 point for final answer. Third one. Contestants were to explain why no copper K radiation will be observed in the radiation emitted from the tube. Okay, so let's look at this situation. The most energetic electron in the tube has energy 5.0 kilo electron volts. This is less than the K-shell ionization energy, which was given in the problem as 8.98 kilo electron volts. So the electrons from the cathode don't have enough energy to create a K-shell vacancy that must be present in order to have your K-alpha emission. Remember, you need to have an electron in the copper to go to that vacancy in order to have that emission of the line spectrum, right? So they don't have energy to have this K-alpha emission to occur. So it's not possible. Okay, so that's the explanation. Finally, contestants were to determine the linear momentum in Newton seconds of a copper K-alpha photon. Now we look at the copper K-alpha photon. It's the same relationship for the linear momentum. The linear momentum is equal to the energy divided by the speed of light. Very simple indeed. So the energy, as given in the problem, the K-alpha photon has energy 8.04 kilo electron volts. So we are going to convert that to nice SI units so we can have our answer in Newton seconds. So we have 8.04 times 10 to the power 3 electron volts. Converting to joule, we will get multiplied by 1.60 times 10 to the power negative 19 joule per electron volt. Then we divide by speed of light, which is 3.0 times 10 to the power 8 meters per second. And if you do the calculation, you should arrive at 4.3 times 10 to the power negative 24 Newton second. 1 point for process, 1 point for final answer, making a total of 10 points. This is the suggested solution from our consultants. Now, contestants, ACCRA Academy. Miracles will never end. I am looking forward to a time when contestants will write and it's immediately projected. Because, you see, this is what I received. This is what I received. And then you see, it was actually demystified for me when I went to read the board. Because, honestly, most of it is illegible. I can't read this handwriting. Anyway, but let's carry on. So when it comes to A, I couldn't read, illegible. When it came to B, the first one, at least it was a little better, even though what they have there is a bit different from what they have here in terms of handwriting. Once again, that's why I was trying to figure out the difference between 1.5 and 1 point something. Anyway. But at least they knew the relationship. If you wanted to find wavelength, Planck's constant multiplied by speed of light over energy, they have something like that. So for knowing that, even though they substituted the wrong energy, they were not looking at the Bremsstrahlung. So even the process was not quite right. But I'm being generous, so I'm giving them 1 point for that. The rest, no, there's nothing else. So they have 1 out of 10. AWUDOME. Your answer to 1 is not acceptable. And then you also knew the relationship to find the wavelength. You have the right relationship. Your substitution is not right because you're using the wrong energy. You're not using the right energy for Bremsstrahlung. And so I'm giving you 1 out of the 2 for knowing this relationship, and nothing else is useful. So you also have 1 out of 10. All right, so now, St. Hubert. St. Hubert, you tried to talk about the spectra. So the X-ray has a diffuse spectra. That's not the proper language. It's a continuous spectrum. And the rest, okay, because you mentioned line spectra. Because you mentioned line spectra for the characteristic X-rays, I'm giving you 1 point there. But you know the right answer is what I gave. Okay. Again, you went to the B. You started looking for the wavelength. You know the relationship. Unfortunately, you are also substituting the wrong energy. So you have 1 point there. When it gets to the momentum, the linear 2, question 2 in B, you again have the right relationship. Your substitution, I don't know where that was leading. Again, you have the wrong energy because you were using the energy from before. So it's a wrong energy, and it's not going to end anywhere. But just knowing the relationship, I'm giving you 1 more point. And then the last bit, which you tried, the third part, that's incorrect. The explanation is not right at all. Okay, so that gives you 3 out of 10. 3 out of 10. That's the end of the problem of the day and the end of round 3. You may pick up your notepads. Round 4. In this round, I'm going to be presenting you with statements. When you receive a statement, kindly consider the statement carefully and let me know whether it's true or false. If you are right, 2 points. If you are incorrect, you lose a precious point. You may choose not to respond, in which case that statement becomes available to the 2 other schools. A school may ring and attempt an answer. If it's right, 2 full points. If it's incorrect, there's that penalty, 1 point. Best wishes to all 3 schools. This time, I'm starting with you, AWUDOME. Your statement. A bivalent consists of 2 chromatids and 1 centromere. Yes, Deborah.
It's true.
No, that's a false statement. ACCRA Academy. A bivalent consists of 2 chromatids and 2 centromeres. Yes, Ajare.
It's false.
You're right. A bivalent consists of 4 chromatids and 2 centromeres. Yes, Dua.
True.
No, that's a false statement. A bivalent actually consists of 4 chromatids and 4 centromeres. Next set. The equation 2x squared plus 6x plus y squared minus 4y plus 2 is equal to 0 represents a circle. Deborah.
It's false.
Yes. The equation x squared plus 5x minus y squared plus 2y is equal to 0 represents a circle. Yes, Ajare?
It's false.
Yes. The equation 2x squared plus 2y squared is equal to 8 represents a circle. Yes, Emmanuel?
Madam, it's true.
Yes. AWUDOME. Since chlorine, atomic number 17, and argon, atomic number 18, are the last two elements in period 3 of the periodic table, argon has a smaller atomic radius than chlorine. Yes, Deborah?
It's true.
No, that's a false statement. Aluminium, atomic number 13, and silicon, atomic number 14, are members of period 3. Silicon has a smaller atomic radius than aluminium. Yes, Sir Jerry?
It's false.
No, that's a true statement. Calcium atoms have larger atomic radius than magnesium atoms. Yes, Emmanuel?
Madam, it's true.
Yes. The dimensions of pressure are identical to the dimensions of energy density. Yes, Deborah?
It's true.
Yes. The dimensions of electric potential are identical to the dimensions of energy density. Yes, Ejare?
It's false.
Yes. The dimensions of angular velocity are identical to the dimensions of velocity. Yes, Emmanuel?
Madam, it's true.
No, that's a false statement. The magnification of a compound microscope is not connected with the focal length of the objective lens. Deborah?
It's false.
Yes. The magnification of a compound microscope is not connected with the focal length of the eyepiece. Yes, Ejare?
It's false.
Yes. The total magnification of a microscope is obtained by dividing the objective magnification by the eyepiece lens magnification. Emmanuel?
Madam, it's true.
No, that's a false statement. Sine of 180 degrees minus A is equal to sine of A. Deborah?
It's true.
Yes. Cosine of 180 degrees minus A is equal to cosine of A. Yes, Ejare?
It's false.
Yes. Tangent of 180 degrees minus A is equal to negative tangent of A. Yes, Emmanuel?
Madam, it's true.
Yes. A good apparatus for measuring enthalpy of reaction must be an isolated system. Deborah?
It's true.
Yes. Sachets of silica gel are placed inside boxes containing sensitive equipment like microscopes to keep insects away. Ejare?
It's false.
Yes. Normally, a fractionating column in a fractional distillation setup provides extra volume to forestall explosions. Emmanuel?
That is true.
No. That's a false statement. It provides greater surface area for separation into pure vapors. Last set of statements. Magnetization is a vector quantity. Deborah?
It's true.
Yes. Magnetic flux is a vector quantity. Ejare?
It's false.
Yes. Last statement. Magnetic flux density is a scalar quantity. Yes, dear.
And false.
That's right. And that's the end of the fourth round. At the end of the fourth round, St. Hubert Minor Seminary and Senior High School has 17 points. AWUDOME Senior High School has 21 points. ACCRA Academy has 31 points. Fifth and final round. In this round, I'm going to be reading out clues. Your objective is to solve the riddle. In order to solve a riddle, you must ring for it. May I hear your bell, ACCRA Academy? Yours, AWUDOME. And yours, St. Hubert. If you solve the riddle on the first clue, 5 points. On the second clue, 4 points. On the third or any clue thereafter, 3 points. There are 4 riddles in all. Best wishes, everyone. First one. I am a fast-swimming organism, but prefer to slowly crawl along the sea bottom. I am an amazing creature, but there are plenty of fun facts to discover about me as well. I appear in folklore as a sea monster. There are many stories about humans being killed by me, but most of them aren't true at all. I'm sometimes called the devilfish due to my appearance. I'm considered to be the most intelligent of all invertebrates. Yes. Go ahead. Which of you? Raphael?
I'm the octopus.
You're right. There was one clue left. I am a soft-bodied, 8-armed mollusk of the order Octopoda. And of course, yes, this is the octopus. They solved the riddle on the 5th clue, 3 points. Actually, it was the 6th clue, 3 points. Next one. I know we constitute an important type of reagent because many systems will not survive without us. But sometimes we are surprised that we are that useful because of our inherent negative attitudes. We strongly resist change. If the change is stronger than us, of course, it may have its way. If changes are known to be small or insignificant, we resist. Yes, Deborah.
A buffer solution.
Yes. The rest of the clues. If changes are known to be small or insignificant, we resist with all our might. We resist changes in pH when small amounts of acids and bases are added to solutions in which we exist. And so, of course, it's a buffer or buffer solution. All right. I was reading the fifth clue, 3 points. Next one. I am a solid geometric figure. I have a base which is normally a polygon. My faces are all triangles. Yes, Raphael.
A pyramid.
Yes. Rest of the clues. The triangular faces have a common vertex. An extreme example of me is a cone. I have made Egypt famous for tourists. And of course, it's a pyramid. They solved the riddle on the third clue, 3 points. Last one. I am an instrument for viewing very small objects at high magnification. I am indeed a microscope. And I have an objective lens. I'm not a light microscope. I use electrons instead of light. Deborah.
The electron microscope.
Yes. The rest of the clues. I use electrons instead of light, allowing me to achieve much greater resolution than an optical microscope. That was actually the last clue. Since I was reading the last clue, 3 points, and that's the end of the fifth round.
I can conveniently pay for my utility bills, my son's Cartoon Network on DSTV, and renew my internet services package. I can securely send my sweet mother her monthly allowance by simply transferring funds from my bond account into hers. I can also pay the gardener through any of the mobile money platforms available. I can verify if the...
At the end of the contest, here are the final scores. St. Hubert Minor Seminary and Senior High School has 17 points. AWUDOME Senior High School has 27 points. ACCRA Academy has 37 points. St. Hubert Minor Seminary and Senior High School, thank you for being here. Best wishes to you. AWUDOME Senior High School, thank you for being here as well. All the best. ACCRA Academy. Congratulations on winning the contest. Please prepare well. Work on that handwriting. And I look forward to seeing you on the next stage, quarterfinals. Viewers, thank you for joining us for this contest. We are still at the 1A stage of competition. Next time, we'll bring you the penultimate 1A stage contest, which will feature Edumai Senior High School, St. Mary's Boys Senior High School, and Islamic Senior High School. Before we leave, I would like to acknowledge that the National Science and Math Quiz is sponsored by the Ghana Education Service through the Conference of Heads of Assisted Secondary Schools. We also have support from GCB Bank, Accra College of Medicine, Medifem Multi-Specialist Hospital and Fertility Center, Lancaster University, Ghana, Academic City College, West African Center for Cell Biology of Infectious Pathogens, WAGBIB, Awake Purified Drinking Water, GTP, MFA Jewelry, and Hoti Makeup. The mentorship sessions are sponsored by Bond Savings and Loans and RMG Ghana, and SciTech Fair 2018 was sponsored by GOIL, Prudential Life Insurance Ghana, and Talo Ghana Limited. Our media sponsors are City FM and Joy News. This is a primetime production. Thank you once again for joining us, and see you next time. Bye.